The power rule in integration is one of the strongest rules. It will recur with us a lot and it's very easy. If we have x raised to any number, we go to the exponent and add 1 to it, take the result here and put it in the denominator and say plus the constant c, just as we are always used to putting plus the constant c in integration. So these are the points. First, raise the exponent by 1, then divide by the new exponent and add the constant c. What matters here, in order to apply the power rule, is that the variable b in the base x is in the base, not in the exponent. The exponent here is a constant number. If we see an x in the exponent, then we need a different rule. The second point, the exponent here can be any constant number, but it must not be -1, because if it were -1 and we added 1 here, it would become 0. And we'd be dividing by 0, and that's something we don't want. So these are the rules we need to memorize, and let's start with something very simple. For example, x squared, we add 1 to it and it becomes x cubed. We take the new exponent and put it in the denominator, don't forget, and say plus the constant c. That's it. That's an integral we've done. If it were 5x to the power of 5, we add 1 and it becomes 6 divided by the new exponent 6 plus the constant c. Okay, if there's a constant before the function, that is 6 with x squared, we take the 6 outside the integral as is and integrate the x squared. It becomes x cubed divided by 3, then plus the constant c. Now we have 6 divided by 3 equals 2, a simple division operation. Same thing here, we take the 4 outside, then do x to the power of 4 divided by 4, the 4 cancels with the 4 and we say plus the constant c. Same thing here, if it's a fraction, we take it outside. Any constant number we can take outside the integral and integrate the x squared as is. Then if there's something we can reduce, we reduce, or here for example 6 3's, we get a denominator of 18 and always plus the constant c. Okay, if the exponent is a fraction, we said if the exponent is a constant number, the most important thing is that it not be -1, then we can do the power rule, we can apply it. For example, if it says the square root of x here, that means the exponent equals 1/2. Same thing, we add 1 to the half, it becomes 3/2, and we take the new exponent and put it in the denominator, then say plus the constant c, then simplify. Here the exponent was 1/3, same thing as long as it doesn't equal -1, and as long as the base is x, we do the same method and say plus the constant c. If it were 3/2, same thing. If the exponent is negative, also the same method. -2 plus 1 becomes -1. Just pay attention to the signs. -1 goes in the denominator as well, meaning the whole term becomes -1/x plus the constant c. -3, same method. So this means the power rule is an easy and simple method that we must memorize. It recurs a lot and applies to very many cases. The important thing is that the exponent not equal -1. Let's now return to the integral of the constant function. If we apply the power rule to the integral of the constant function that we saw in the previous lesson, if we say the integral of 5 without an x, we can assume there's an x next to it and a 0, because any number to the 0 means it equals 1. As long as the 0 doesn't equal -1, it means we can apply the power rule to it. We add 1 to it here and divide by the 1 and we get 5x plus the constant c. So we arrived at the same result for the integral of the constant function. This clarifies for us the accumulations we saw in the previous lesson, whether the k was 6 or 5 or 2. We now move to a special case, or we want to alert once again. If the exponent equals -1, then we'll be forced to divide by 0, and that's something we don't want. So it means we need another rule, which we'll study in the next lesson.